We'll break this video into 4 quick parts. Part 1, Vertical and Horizontal Lines. Part 2, the 3 forms of linear functions. Part 3, Converting equations to slope-intercept form. Part 4, Using equations of linear functions to solve problems. Each part is short and builds on what you already learned about slope and graphing. A vertical line goes straight up and down. Every point on the line has the same x value. So if the line goes through the point, B, the equation of the vertical line is simply x equals a. This means x never changes, it always stays equal to that number. A horizontal line is completely flat. Every point on this line has the same y value. So if the line goes through A, B, the equation of the horizontal line is y equals b. That means y stays constant no matter what x is. Now we're in part 2, where we look at the 3 main forms of linear equations. The first one is called the point-slope form. Point-slope form is useful when we know 2 things: the slope of a line, and one point that lies on the line. If we know a point, x1, y1, and the slope m, then we can write the equation like this. Y minus y1 equals m, x minus x1. This equation is basically saying, starting from the point, x1, y1, the slope tells us how the line moves. Point-slope form is great when the problem gives us a point and a slope directly. Now let's compare the 3 forms of linear functions all in one place. Each form is useful in different situations, so understanding when to use each one will save you a ton of time. First, we have the slope-intercept form. Y equals mx plus b. We use this form when we're given the slope and the y-intercept, or when we want to graph quickly. If the equation already looks like y equals, this is the easiest form to work with. Next is the point-slope form. Y minus y1 equals m, x minus x1. We use this when the problem gives us a point and the slope, or even when it gives us 2 points, since we can find the slope and plug in either point. This form is also useful when rearranging slope formulas. If you know one point and the slope, point-slope is the fastest form. The third form is the standard form. Ax plus by equals c. This form is great when a problem involves both x and y-intercepts, or when you want to work with integer coefficients. It's also helpful when solving systems of equations, especially with elimination. Standard form avoids fractions, so it's often preferred in real-world or application problems. So now that we know all 3 forms and when to use them, let's practice converting equations into slope-intercept form. Now let's practice converting equations into slope-intercept form, which is y equals mx plus b. Our goal is always to solve for y. Starting with example 3a. To convert to slope-intercept form. First, we want to get the 2y by itself. So we add 3x to both sides. After adding 3x to both sides, the equation will now be 2y equals to 3x plus 7. Next, divide everything by 2 to isolate y. After dividing by 2, the equation will become y equals to 3 halves x plus 7 halves. In example b, start off by isolating negative 6y. To isolate negative 6y, subtract 12x from both sides. The equation will now be negative 6y equals to negative 12x plus 9. Next, divide everything by negative 6. After dividing by negative 6, the equation will become y equals to negative 12 over negative 6x plus 9 over negative 6. This can be rewritten as y equals 2x minus 3 halves. Now let's convert this equation into slope-intercept form. We're starting with y plus 4 equals negative 1 half, x minus 3. Our goal is still to isolate y. First, we distribute the negative 1 half across the expression, x minus 3. When distributing, the negative 1 half will multiply to x and 3. This will become y plus 4 equals to negative 1 half x plus 3 halves. Now we want y by itself, so we subtract 4 from both sides. Next combine 3 halves and negative 4. To subtract them, 4 will need to be rewritten as a fraction with a common denominator. In this case the common denominator will be 2. To get 2 as a common denominator, multiply the numerator and denominator of 4 over 1 by 2 to get 8 over 2. This will then change 3 halves minus 4 to 3 halves minus 8 halves. 3 halves minus 8 halves is negative 5 halves. This will make the equation become y equals to negative 1 half x minus 5 halves. Now we'll write the equation of a line when we're given one point and the slope. We'll use point-slope form and then simplify to slope-intercept form. We start with the formula. Y minus y1 equals m, x minus x1. Next substitute the values. The values will come from the point negative 4, 1, and the slope negative 3. This will make the equation become y minus 1 equals negative 3 times x minus negative 4. Next, clean up the double negative. Minus a negative becomes plus, so minus, negative 4, becomes plus 4. So now the equation is y minus 1 equals negative 3 times x plus 4. Next distribute the slope. This means multiply negative 3 with x and 4. This will become y minus 1 equals negative 3x minus 12. Next isolate y by adding 1 to both sides. This will become y equals negative 3x minus 11. This problem is about finding the equation of a point using two lines. We are given 2 points, negative 3, 2, and 2, negative 4. Because there is no information about the slope, we will have to start by finding the slope, then write the equation using point-slope form, convert to slope-intercept form, and then change it to standard form. Step 1, find the slope. Use m equals y2 minus y1 over x2 minus x1. This will be negative 4 minus 2 over 2 minus negative 3. This will simplify to negative 6 over 5. So the slope is negative 6/5. For step 2, use point-slope form. Y minus y1 equals m, x minus x1. Choose the point, negative 3, 2. Substitute the point and slope to make the equation, y minus 2 equals, negative 6/5, x minus, negative 3. Because subtracting a negative becomes addition. Rewrite the equation as y minus 2 equals, negative 6/5, x plus 3. For step 3, distribute the slope. So multiply negative 6/5 to x and 3. That gives y minus 2 equals, negative 6/5, x minus 18/5. For step 4, solve for y. Add 2 to both sides. Rewrite 2 as 10/5. Negative 18/5 plus 10/5 equals negative 8/5. So the equation in slope-intercept form is y equals, negative 6/5, x minus 8/5. The last step is to convert to standard form. Multiply every term by 5 to clear the fractions. This will become 5y equals negative 6x minus 8. Finish by adding 6x to both sides. This will result in the equation becoming 6x plus 5y equals to negative 8. Therefore the standard form of this line is 6x plus 5y equals negative 8. This problem asks to determine the y-intercept using 2 points. The first thing to do is to find the slope of the line. To find the slope of the line, use slope, or m, equals to y2 minus y1 over x2 minus x1. Then put the points into the formula. This will be slope equals to 10 minus 5 over 4 minus negative 2. This simplifies to 5 over 6. Next, use a point to substitute the numbers into slope-intercept form. Since point, 4, 10, are both positive, it is more preferable. When substituting point, 4, 10, the equation will be 10 equals to 5 over 6 times 4 plus b. Recall, this problem is asking for the y-intercept of the line. Also recall that the y-intercept is b in the slope-intercept form. So the last thing to do is solve for b. Since 10 is a whole number, it will have to be converted into a fraction to subtract 5 over 6 times 4. Use 10 is equal to 60 over 6 to have a common denominator of 6. Substitute 60 over 6 for 10 to make the equation b. 60 over 6 equals to 5 over 6 times 4 plus b. Multiply 5 over 6 by 4 to get 20 over 6, so 60 over 6 equals to 20 over 6 plus b. Next, subtract 20 over 6 to both sides to isolate b. 60 over 6 minus 20 over 6 is 40 over 6. So b, the y-intercept, is equal to 40 over 6. 40 over 6 can also be rewritten as 6 2/3. This problem is about finding the slope of an equation in standard form. To find the slope, you will convert the equation into slope-intercept form, or y equals mx plus b. Begin by subtracting 4x to both sides. This will make the equation 3y equals negative 4x plus 12. Next, divide every part by 3. This will make the equation y equals to negative 4/3 x plus 4. Recall, when an equation is in slope-intercept form, or y equals mx plus b, the slope is represented by m, which is attached to x. So for this equation the slope is negative 4/3. This problem asks to find the slope and y-intercept of a line that is in standard form. Like the previous problem, to find the slope and y-intercept you will convert standard form into slope-intercept form. To convert to standard form, start with subtracting 4x to both sides. This will make the equation 5y equals to negative 4x minus 10. Next, divide the whole equation by 5. After dividing by 5, the equation will be in slope-intercept form. The equation will be y equals to negative 4/5 x minus 2. Negative 4/5 is located where m, the slope, is, and negative 2 is located where b, the y-intercept, is. So the slope is negative 4/5 and the y-intercept is 0, negative 2. That is the end of our lesson on linear equations. In the next video, we'll cover parallel and perpendicular lines.